This is the final experiment of Ph4454 reciprocity calibration. Reciprocity calibration is a very powerful method of performing an absolute calibration on a microphone or a hydrophone. The reason it's so powerful is because it doesn't require the use of any other transducers for which you know the properties. Another common method of calibrating a hydrophone or microphone is the comparison method, where you take another hydrophone or microphone for which you have an absolute calibration, often supplied by the manufacturer, and then you compare your unknown transducer to the calibrated transducer. In this case, what happens if you don't have another calibrated transducer to compare it to? That's when you do reciprocity calibration. So in this case, we're going to use a B&K hydrophone as our unknown hydrophone, which needs to be calibrated. And we're going to use two other transducers to help us do the calibration. The first one right here is the F33. This is an old style Navy transducer that's been around for a long time. This one was custom made for us a few years ago. And it will be a reversible transducer, so we can use it both as a transmitter and a receiver. And then the other transducer is this one here. It's an ITC 5292, also a fairly old unit, and it will be used just as a transmitter. The F33 hydrophone is actually a pretty old design. It's made up of a bunch of small piezoelectric blocks that are spread around inside here in an array. And there's actually two arrays. There's a center array and then an outer ring array. The hydrophone is then potted with oil, and then there's a flexible membrane stretched across the surface here. So the oil acts as an impedance match to the water. So what you'll notice is that one side is soft. This is the transmitting side. And then the back side is just a hard urethane. The ITC 5292 is a similar design with an array of piezoceramic elements inside. It, however, does not have a flexible membrane. This is a hard urethane membrane. And then obviously with the cable coming in the back, this is not an active phase. The hydrophone that will be acting as our unknown transducer is a B&K type 8103 hydrophone. It measures about 2 centimeters in length and about 1 centimeter in diameter. It's a simple type of hydrophone that uses a piezoceramic cylinder that is radially polarized and then potted in a urethane rubber compound. We have a data sheet for the B&K 8103 hydrophone. It includes the open circuit voltage sensitivity, in this case in decibels referenced to 1 volt per micropascal. This calibration is done at 250 hertz, but there's also a chart showing the sensitivity versus frequency.